In this video, I am going to show how to project twilight circles. Twilight is a faint light of the sun when the sun is below the horizon. Normally, 3 twilight circles are projected on an astrolabe. These are civil twilight when the sun is at 6 degrees below the horizon, nautical twilight when the sun is at 12 degrees below the horizon, and astronomical twilight when the sun is at 18 degrees below the horizon. Projection of twilight circles are almost similar to altitudes, but as they are projected below the horizon, there is slight change in the formula. So let's start. Let's start with a diagram after projecting horizon circle. From the center C, draw a line segment to the point Tn at an angle A below the north horizon. Now draw a line segment from the point S to this point Tn, intersecting the equatorial line at point H. CH is a part of the diameter of a twilight circle. Now draw a line segment from the center C to the point TS at an angle A below the south horizon. From the point S, draw a line segment passing through TS to the point I on the equatorial line. CI is another part of the diameter of twilight circle. Draw a circle of diameter HI passing through the points H and I, having a center on the equatorial line. Now let's find the formula for twilight circles. The horizon is at an angle phi from the north pole. Draw a line segment from the center C to the point Tn on the circumference at an angle A below the north horizon. Hence the angle NCTN is phi plus A. Now from the south S, draw a line segment to the point Tn, intersecting the equatorial line at point H. The angle CSH will be half of NCTN, that is phi plus A by 2. Now in a right angle triangle, HCS 10 phi plus A by 2 is equal to CH upon CS. Rearranging the formula, CH, which is the part of the diameter of twilight circle towards north, is equal to CS, which is the radius R of the equator, into 10 phi plus A by 2. So this is the change in the formula of twilight circle as compared to the altitude. Phi minus A is replaced by phi plus A as it is below the horizon. Now draw a line segment from the center C to the point TS at an angle A below the south horizon. Therefore the angle SCTS is phi minus A. Extend this line segment towards the north. Draw a line segment from the point S to the point TS. Hence the angle NSTS is phi minus A by 2. Draw a line segment from the point S passing through the point TS to the equatorial line at point I. The angle TSSI is right angled. Therefore the angle CSI is 90 minus phi minus A by 2. Now in right angle triangle, SCI 10 90 minus phi minus A by 2 is equal to CI upon CS. Rearranging the formula, CI is equal to CS into 10 90 minus phi minus A by 2. Ci, which is the another part of the diameter of twilight circle, is equal to Cs, which is the radius R of the equator, into 10 90 minus phi minus A by 2. Using this formula, find out the diameter of the circle of twilight. Draw a circle of diameter HI having center on the equatorial line and passing through the points H and I. Here it completes the projection of twilight below the horizon. In the next video, I will show how to project prime vertical. Please subscribe to my channel to get updates on upcoming videos on an Astrolabe.